Good morning, students. This is Bhavna Sinha, your chemistry teacher, and this is the fifth video for this week. As you all know, we are discussing the chapter P blocked elements, and in that, we are discussing group 16 elements. Okay, so let us proceed with that only. Today, we are going to discuss atomicity first. Now, what is atomicity? See, atomicity means in what atomic state it is found in nature. Then oxygen is found in which form? In gaseous form. And in which state? Diatomic state in nature. The diatomic state of oxygen is O2. Okay, O2. Oxygen exists in nature in this form. So two atoms of oxygen have combined here. So it is the diatomic nature of oxygen, and oxygen is found in the gaseous state. Oxygen is found in which state? Oxygen is found in the gaseous state. Whereas the other elements, okay, the other elements, they are found in what we call solid state. They are found in solid state. Okay. The other elements include which elements are present other than oxygen? Sulfur. Okay. Selenium. Selenium. Tellurium. And last one is polonium. So these are the other elements present in group 16 other than oxygen. And only oxygen is found in gaseous state in diatomic form, whereas these all sulfur, selenium, tellurium and polonium, they are existing in solid form in nature. Okay, they exist in solid form in nature, and sulfur especially, it is found in octatomic state, that is polyatomic state. Sulfur is found in which state? Sulfur S8 state. Okay, and what is the bonding? Let us see the bonding of sulfur in that. One sulfur, single bond with other sulfur, single bond with other sulfur, single bond with other sulfur, single bond, single bond, single bond, single bond. Like this, each sulfur atom is present by single bonding with the other sulfur atom, and in this way 8 sulfur atoms are attached to each other in the octatomic or polyatomic form of sulfur. Okay, so and what is the bonding in O2? You can see here O2, it is O double bond O. Okay, so this is the atomicity. Oxygen is found in gaseous state and it is diatomic by nature, whereas the other elements of this group exist as solid. Now maximum covalency. Oxygen covalency is constrained to 2, yet the covalency surpasses 4 in alternate elements because of the accessibility of d orbital in them. D orbital is present in all the other members, and due to the presence of that, oxygen has covalency constrained to 2 only. That means it has covalency of 2. Okay, so this is the atomicity. Okay, now let us see the formation of M2 minus ions. Oxygen, because of its high electronegativity, oxygen has high electronegativity, and the reason is that it can either gain 2 electrons or it can either share 2 electrons. Okay, oxygen can either gain 2 electrons or it can share 2 electrons, and other elements also, like sulfur is there, selenium is there, tellurium is there, polonium is there, they can also either gain 2 electrons or they can share 2 electrons. Okay, now Oxygen, because of its high electronegativity, indicates negative oxidation state and does not demonstrate any positive oxidation state, aside from OF2 and O2F2. OF2 oxygen fluoride, O2F2 dioxygen difluoride. Okay. So this is the formation of M2 ions. Okay, how we can see what happens in OF2. Let us see what happens in OF2, how this compound is formed. So OF2. Now we know oxygen has 6 electrons in the outermost shell, and 2 fluorine atoms are there. They have 7 electrons in their outermost shell, each one of them. Okay, these are the 7 electrons. Another fluorine also the same 7 electrons. Okay, so this is the dot electronic structure of O and F. Now let us see what happens in OF2. This O and F, both the F, they share one electron. So this is the 1 electron of oxygen, this is of fluorine, it becomes stable. This is of oxygen, this is of fluorine, it becomes stable, and the oxygen becomes stable like this. Okay, so this is the bonding in OF2. Now when we will show the bonding here, O will be in the middle, this side single bonded F, and this side single bonded F. Okay, so this is the bonding in OF2. Okay, now see, let us see the other point, hydrogen bond formation. So on account of its little size and high electronegativity, oxygen shapes solid hydrogen bonds. Alternate elements in the group have relatively low electronegativities, okay, and don't shape hydrogen bond. Okay, since oxygen has small size and it has high electronegativity, the electronegativity of oxygen is high, and since its atomic number is only 8, so its size is also very small because it has only 2 shells. Okay, the first shell contains, you can see here, the structure of oxygen. It is the what we call nucleus, and this is the first shell and this is the second shell. So it has a very small size, and because 2 shells are present in it only, and it has high electronegativity. The electronegativity of oxygen is high, and due to the presence of these two factors, little size and high electronegativity, oxygen can form solid hydrogen bonds with hydrogen. Okay, oxygen is capable of forming hydrogen bonds, and which type of hydrogen bond? Solid hydrogen bond. And the reason is, there are 2 reasons. First, the little size of oxygen atom, the small size of oxygen atom, and the second is the high electronegativity of the oxygen atom. Okay, now the other elements which have low electronegativity and relatively high size, they don't form hydrogen bonds. When they are reacting with hydrogen, they are not forming hydrogen bond due to the presence of high electronegativity, very high electronegativities they have, and the larger size of their atoms. Their atomic size is also large, and they have high electronegativity. They have low electronegativity in comparison to what we call oxygen, and due to the presence of these two factors only, they don't form hydrogen bond with hydrogen. On the other side, oxygen forms hydrogen bond, and that also which type of hydrogen bond? Solid hydrogen bond, due to its smaller size and its high electronegativity. Okay, So this is all about hydrogen bond formation of group 16 elements. Rest we will discuss in the next class. Thank